were 5 to 10 times higher CO2 in the atmosphere than we are today. So I don't get excited about even another doubling of CO2. In order to get the huge increase that the IPCC wants, they have to use some feedbacks. In other words, they say, add CO2, it's going to increase the temperature, put more water vapor in the air, and that gives you a feedback and it heats it more. So it's really not CO2, it's the water vapor. However, many of us think that's wrong, because if you look at the data, I'm talking ice core records now, the temperature goes up first, then the CO2. And I think it has to do, at least in part, because you heat the oceans and they degas. Now you can do this very nicely on your own. Take everybody, no kids, take 2 bottles of beer. Put one in the back window of your car on a hot sunny day, get it way up there. Put the other one in your freezer till it's just about ready to freeze, so that when you open it, little ice crystals. That's when it's the best. But if you take those 2 bottles of beer very carefully and pop the caps, what happens to the hot one? Yeah, it's probably going to erupt like a volcano. And the reason is the CO2 in the beer is coming out of solution in the hot one. In the cold one, you won't see anything. Because the colder the liquid, the more CO2 it will hold. And that's what happens in the oceans too. By the way, don't try that in your living room. Your wives won't like it. So, yes, sir?
Talking about gas coming up out of the ocean. Methane hydrate. Turns from on.
Tire another story. But we think that plays a role in some of the things we've seen in past history, but there's some problems with that too, because I think what they're trying to do with that, they're trying to do it too quickly, and I don't think the process is that quick. But it's another interesting story. Okay, well, let's look at this again. So is CO2 the main climate driver? Well, another way of looking at it, does most of the warming that we've seen result from an increase in greenhouse gases, especially carbon dioxide? The main support for the CO2 hypothesis comes from computer climate models. So let's take a look at those models. How well, now this is from the IPCC statements, and they run the models, and this is what they say. They claim to have a good understanding of the greenhouse gas effect. Ozone, they know, has some kind of an effect, but they don't quite know what it is yet. It's another interesting story. Aerosols, well, they're not really sure what they do at all. Some say they heat, some say they cool, depends on the aerosol, so that's kind of a problem. Land use effects changes the albedo, how much sunlight is absorbed, how much is reflected, this type of thing. They don't really understand that, can't put it in their models very well. This is the one I like, solar influences. They claim that the understanding there is very low. They don't know how the sun affects the climate. Whoa. So here's my question. If you don't understand what's going into your computer model, how good's the output? See, I used to work in the computer industry, and we called this GIGO, garbage in, garbage out. So, well, President Clinton asked the National Science Group to run some computer models and project what's going to happen in this country. So they took a good Canadian model, and then the Hadley models out of England, they're supposed to be some of the best. And they started running it, and all it was double CO2 and tell us what's going to happen to the rain. Well, you see, California looked pretty good. I mean, a pretty good agreement. But once we get down to here, into the Rio Grande area, now they're diametrically opposed. They're exactly opposite. We get down here, this is kind of Minnesota, the Red River. And the Canadian model says we're going to be a cold, wet swamp. And the Hadley model says it's going to be a desert. They can't be both right, can they? So which one are you going to believe? Which one do you want to hang your future on? I'm going to go with either one. Okay, and then they do all kinds of projections. Back about the year 2000, they ran their series of scenarios, they call it now, and this is what they predicted would happen with temperature. Well, this is what actually happened. The Earth didn't get the memo. Okay, here's another test. CO2 goes up, temperature's supposed to follow. Well, temperature's going down. The experiment's been run. It failed. This, at the very least, says that something else out there is having an effect, and in this case, greater than the CO2 effect. Okay, well, I just mentioned this. This lack of correlation agrees with the record in ice cores and in geologic history. CO2 is not driving climate based on that record. Okay, well, let's look at the other half. What of the solar hypothesis? Well, solar activity is cyclical. We know it drives the Earth's climate. It's the main energy source for Earth's climate. I mean, if you change that energy source, it has to change the climate. It's cause and effect, very simple. The Earth, however, is buffered, so it is not too drastic a change. But the IPCC in their climate models uses only total brightness of the sun. It's about 20% of the effect. Other things such as the solar wind, that massive bunch of charged particles that comes out and blasts the Earth and causes, among other things, northern lights. How many remember those from the 2000, 2002? Really spectacular, right? Did you see those last month? I didn't either. There wasn't any. See, the sun's very inactive now. But the solar magnetic field makes all sorts of changes that affects the Earth's magnetic field. And this is the main climate driving effect. And the IPCC does not even consider it. Let's look at some cycles. We got the sunspot cycle, about 22 years. We got the Maunder minimum cycle, which is 800 to 1,000 years, cyclical. Probably gave us a little ice age in the medieval warm period when the Vikings were in Greenland. Then we got the Gleesberg cycle. It's about 75 years. Probably gave us the hot, dry years in the 30s, the cooling here. Recent warming, and today the cooling again. So the sun rules. These cycles have very good correlation with climate change. On the annotated bibliography I gave you, there's one entry there that dates from 1978. Now, why would I put something in that's 31 years old? Because it's written by NASA people, and they documented all of the correlations between solar activity and climate change on Earth. We've known about this for 30, 40, 50 years. But yet, somehow, it does not register with certain scientists today. Well, the length of the sunspot cycle is a very good indicator of what the solar activity is. Short cycles require a very active and warm sun, warms the Earth. Long cycles, we see cooling on the Earth. So let's look at what's currently happening with the sun. Now, we've got to look at two things here. First, this came out in September of 06, about 3 years ago. This is a NASA projection. They had plotted the solar activity during the last cycle, and back here when we saw all those marvelous northern lights, the sun was very active. And they said, well, this is going to cool right down, and it's going to turn right around, and we'll have an even more active cycle. And you see, watch this point right there. That's 207 and a half. Now, this is the last one that they put out. See, this is October of 09. You see, now they've had to move that point from way back here, almost 2.5 years. You see, the sun didn't get the memo. You know, it didn't turn